There are 86,400 seconds in one day. But what actually is 1 second, and how do we standardize that? Today is day 3 of learning something new every day about the world around us and teaching you guys about it. And today we're talking about how time, specifically 1 second, is regulated. The concepts of the second and the minute actually go back to ancient times, and they originated with the intention of just purely astronomy, not even timekeeping. And so 4,000 years ago, the Sumerians decided to divide the circle into 360 degrees. And then around 1,000 years later, the Babylons came in and decided to divide the sky into 360 degrees. And then around the year 150, some ancient Greek philosopher was like, let's split each degree into 60 minutes, each minute into 60 seconds, which brings us to how we conventionally know time now. But that's not actually how we define the second today. 1 second is actually standardized differently ever since the 1950s, when scientists found out that the duration of our day on Earth is actually changing. And it can change due to multiple factors, like strong winds even, or a very strong earthquake in Japan, for example, can actually change the duration of a day by up to 3 microseconds. We also needed a more accurate way to standardize seconds because 1 over 86,400 was not enough of an accurate definition to make sure our clocks stayed in sync as well. Now come the atomic clocks, and that's actually how we define 1 second. And we use a cesium atom today to define 1 second. And the way this works essentially, I'm gonna avoid some sciencey jargon, but if you shine a light at a certain frequency at the cesium atom, what's going to happen is the electrons of the atom are going to jump up and down energy levels. And so essentially the frequency of these oscillations is kind of what defines a second. And so the conclusion that we have come to is that those cesium electrons, they oscillate 9,192,631,770 times in 1 second that we've previously known before. And that's how we define 1 second, the amount of time it takes for cesium atoms to go that many times back and forth. And that's how all of our digital clocks, our iPhones, when the power goes out, that's how we retain time, and that's how we retain the synchrony of all of our clocks together through that universally defined way that we use atom clocks. If you like this video, follow along to join our learning journey.